Hi, this is Jack Polson, and the purpose of this JOLT is to show you how to compile MPI on your own machine. So this is an alternative to the other JOLT, which show you how to install a pre-built Debian virtual machine which contained an already compiled MPI environment. So you should go this route if you're a little more familiar with the command line and don't mind compiling your own software. So if at any point you can't follow any of these steps, just remember you can go back and use the virtual machine. Okay, so the first thing we want to do is make sure that we have a working C and C++ compiler installed. So go ahead and open up a terminal. Whoops, sorry about that. So on most machines, you can see if GCC is installed somewhere. So if you type which GCC, it tries to find it, and if it does, it prints out a path. Now, if we tried something which we didn't have, which I don't think we have, actually we do have Clang. I don't know, if we tried a compiler we don't have, like ICC, you'll see that nothing is returned. So what I want you to do first is to make sure that you have at least GCC or Clang installed. So once you've verified that you do, what we want to go ahead and do is download mpitch, which is a very popular flavor of MPI, which was developed at Argonne National Laboratory. So if you just go to www.mpitch.org, you'll see the website come up, and there's a download link that will be on the site. It doesn't matter if it's the same version as what's available here. We're just going to go ahead and download the most recent release. So we'll save that. It's about 10 megabytes, so it doesn't take too long. Now we want to go back to the terminal, and at least on this machine, the file was downloaded into the downloads folder. Now I've already actually installed mpitch on this machine, but I want to show you how to install it from scratch. So we're going to move the tarball, which on this machine was located in the downloads folder. It was called mpitch 3.0.3. So we move that into the current directory. You'll see there's a tar.gz file. So we're going to untar it and unzip it in one command. Okay, so after we untar the file, we'll notice that there's a directory named mpitch-3.0.3. So if we move into that directory, we'll notice that there's a utility named configure that's located in this folder. It's part of what's called an AutoTools build system. So the main thing that we need to notice is that when we run this configure routine, what it's going to do is check for a lot of different properties of the system, like which compiler you're using, et cetera, et cetera, et cetera. But what you want to specify is the installation directory. So after we've built the software, we want to move all the compilers into a particular directory. So the way you do that is through the prefix command line argument. So our home folder looks like home Debian, because the username is Debian. If your name is, I don't know, Tim, then this might be home/Tim. And so if we install it into a folder named install, then you would have this command. So we're going to go ahead and run that. And this is going to take a few minutes, so we're going to speed this up. Okay, so we'll notice that after the configuration ended, we see that the last line printed was configuration completed. If you see something that says error, then odds are that there was a mistake and you may need to go back and make sure that you have compilers properly installed. Okay, so now that the configuration is done, we can go ahead and actually build the executables, which we can do just by typing make, which again will take a little while, so we're going to speed up this step. Okay, so after we finish with make, and after it finishes running, we'll have the MPI compilers ready. So at this point, what we want to do is actually move them into the folder that we'd originally specified to install them, which in our case was home Debian install. So just ignore what's here. We're going to type make install, and that will go ahead and again move the MPI compilers into home Debian install. All right, so if we want to go look in that folder, we'll move to home Debian install. That is what? Sorry, home Debian install. And then in the binary folder, we'll notice that we have our MPI-C compiler, which is MPI-CC, and then our MPI-C++ compiler, which is MPI-CXX. And we actually also have MPI Fortran compiler, which there's an MPI F90 would do an MPI version of Fortran 90, and MPI F77 would do an MPI version of Fortran 77. So what we're going to do now is compile just a very simple hello world program. So ignore those last two commands. So we actually have a hello world program already set up on this machine, which I'm just going to copy over. So it's in this case, in the virtual machine, which is described in another JOLT. It's in an examples folder, and in C there's a file named hello.c, which we're just going to copy to this folder. Okay, so hello.c is in this folder. If we open it up, it's a basic hello world for MPI in C. I don't really want to go over the details at this point, but basically what happens is that you initialize MPI with this line. You find your process ID or rank. So if you have 8 processes, the ranks in this case would be 0 through 7. And then the number of processes is called the communicator size, which is found here. And then you print what your rank is, how many processes there are, and then you clean up MPI. So if there were 8 processes running this program at the same time, then you'd see hello world from process 0 of 8 all the way through hello world from process 7 of 8. Okay, so the important thing though right now is just to verify that we can actually compile this hello world program with our new compilers. So what we can do is run MPI-CC, which is an MPI-C compiler. We run that on hello.c, and then we tell it that the output is going to be a program named hello. So we notice that ran without a problem, and so if we want to run this hello world program with one MPI process, you just run it as normal. And we see that if there's one process, its rank will be 0. But if we want to run with many processes, we need to use the MPI run command. And then we tell it that the number of processes is, I don't know, 8, which would launch 8 separate processes. And then we run the program normally. So now we see that, that each different process has its own unique rank. And so, for instance, the 5th process will say hello world from process 5 of 8. Okay, and of course there's a simple C++ equivalent of that we can verify really quickly, which on this machine happens. There's a simple example that I'll copy over. Okay, so if we look at the hello.cpp, it looks essentially the same as the C version, except it's a little more C++-like in that we used iostream rather than stdio.h, and then we use cout instead of printf. But again, the contents of the hello world aren't all that important. I just want to show you how to compile a simple C++ code with MPI. So we'll type MPI CXX, which is the MPI C++ compiler. In particular, we want to use the one in this folder. So we do /MPI CXX. And then hello.cpp is the name of the source file, and we want the output to be hello. So we're going to overwrite the old C one. Okay, so if you want to run on one process, you just type /hello. If you want to run on, say, 6 processes, you say the number of processes is equal to 6, and then you run the file. Okay, so this concludes the tutorial. What I really wanted to do is show you how to compile mpitch to set up MPI compilers on your own machine. And again, if you had any problems with this tutorial, you may want to go ahead and look at the other JOLT, which showed you how to install a virtual machine which already has the compilers set up. And in particular, we're actually running this tutorial from that virtual machine. Thanks.